Okay, I think we are ready to start. Thanks for coming to this talk and not coming to the space one in the keynote hall. So at least a few people are interested in types, because for the next 45 minutes, that's what we will talk about. Don't be scared, this will not be a very philosophical thing. Maybe the first half of it, but you will see a lot of code, don't worry. So make it to the first half and then we'll talk about code. Now, by the end of the talk, I hope that at least some of you will be convinced to at least consider replacing some of your primitives with more types and using types much more in your code. So if there's one in the audience afterwards, I think this talk will be worth it. So I want to start with a question. Do you enjoy debugging? And maybe some of you do. I mean, there's this puzzle-solving thing, right, with it. Like, I don't know, you're like colleges trying to understand why this code is breaking. But to be honest, in our daily work, most of us do not agree on this, and we don't enjoy debugging. I do test-driven development to avoid debugging most of the time. So imagine a world, an ideal world, where with the right programming language, buggy code is impossible to write, just because the compiler will refuse to compile and to build your buggy code. That would be amazing, right? I mean, it's a dream, but it's an ideal world. I mean, we've all been to a university, probably, and we know that no language will ever prevent us from writing a bug. I mean, Alan Turing, halting problem, things like this. But it's still nice to have this idea in mind, and maybe we can try to avoid writing those bugs and finding as many bugs as possible as early as possible. So let them find by the compiler, not by your QA, not by your customer. So, and I think the solution for this are types. And I found this quote from '78, well-typed expressions do not go wrong. And I think this is true. The problem is that very often we are not writing well-typed expression in our daily works. So what is a type? Let's first do a definition so that we're all talking about the same thing. I found this one. A type is abstraction mechanism over data. To be honest, that's very generic. So I tried to find a better one, and I came up with this. A type is a formal description of the behavior of a program fragment. What I found interesting about this one is that it contains the word behavior. So type is more than just a few data values, right? So let's keep this in mind while we are talking about types during this talk. So to understand why types are so important, I think we should go back to a world, to a time when there were no types. So let's start at the 50s. There were a few programmers there, right? We already had program languages. But types were pretty much absent back then. We didn't have types, especially not in the way that we have them today. There's a bit of the legend that types started with Fortran, which was a very popular language in the 50s. And so actually, in the Fortran manual for 1956, you will find this sentence, two types of constants are permissible, fixed points and floating point. The thing is that this word type is exactly twice in this whole manual. Most of the time, they actually talk about modes. So that they say type is just a language thing, right? They didn't mean it with a specific meaning. They had two modes. So it was not exactly what we mean with types today. So researchers think that by 1960, with a language called Algol 60, types were born. And when we look into this, it actually says, integers are of type integer, all other numbers are type of real. And they use the word type as a specific noun. It had a meaning all of a sudden. If you never heard of Algol, it was like a language family, committee-driven. So committees would come together and define the next version of this language. And Algol 60 was from 1960. And then the whole story started. And I found this quote from a developer called Tony. You might have heard of Tony before, because there's a famous quote about $1 billion mistake that a lot of Kotlin developers know. That's the same developer. He also invented things like quicksort. So he has quite some history. And he said, like in the 60s, you know, the result of any program should be comprehensible without knowing anything about the machine or its storage layout. And he thought that types are the goal for this. So types are not only for memory requirements. So an integer needs a certain amount of bytes. But if you have two programs, the same program running on two different machines, they should give you the same result. And we didn't have this in the 60s or the 50s. So he said type is the solution to this. We have to abstract this. And his suggestion came into a language called Algol W. You might wonder why this doesn't have a year. Algol W, although it was influencing a lot of languages afterwards, never became official standard, unfortunately. But all these developers work in Algol, they worked on languages you have heard. So let's keep going and go to the 70s. And types, there was one thing missing when it came to types to compare to what we have now. And I found this article from 1973 from James Morris, another famous computer scientist. And he said, you know, the type system should guarantee that only specific operations on a type should be possible. So an integer type, only the integer operations should be allowed there, right? That was like this, there. But for all the user-defined types, it wasn't like this. And today, we're creating a class and adding a method, and we can only call these methods, right? For us, that's totally normal. But it wasn't like this before. So he suggested we need to fix this. And it was fixed in a language called Pascal, which is a direct, it was done by those people who did Algol W. And Pascal had a lot of variations of create custom types. And researchers basically say that with Pascal, types became the central feature as we know it today. And this was the 70s. We could basically directly jump to 2010 when Kotlin was born, right? Maybe we should have a quick look what's happened since then. Just like a brief overview through the decades with types in mind. So the 80s, the dawn of object orientation, right? Starting with Smalltalk, C++, Objective-C, that's OO, kind of as we still do it. So the type structure we use for abstracting, for modeling, all of a sudden. And a type was basically a class, which how we mostly still perceive it today. The 90s, like the age of languages like Java. We heard just a lot about how Java evolves from Jake. It all started in the 90s, as he also showed. And then this little ugly brother, J#, which later becomes C# and all of those. There's a problem that Java still tries to fix, and Kotlin fixed for us. A lot of the boilerplate we had to write of Java, and I found this nice quote. You know, object-oriented languages made static typing so painful that many of us just gave up on it. And this kind of defined the next decade, because dynamic type languages appeared. JavaScript, Ruby. So we kind of gave up on static typing, right? That doesn't mean there are no types. They're called dynamically typed languages. So they're not typeless. It's just a difference when we enforce the types. All the types are still there. That's why the Ruby developers like to do TDD, because they can check the types in the tests at least. But still, I played with Ruby a while ago. It was nice, but I don't know. It wasn't the original idea of like all these researchers who tried to give us the compile time safety, right? So, but they're there and stayed for a while. But then something happened in Java. Jake just mentioned as well. Generics happened. And I found this nice quote by Bill, who was working on the generics. You know, after you ship, fixing a bug costs like 10,000 times as much as catching it in the first place. And generic tries to push this boundary bit to the compile time by giving us more safety there. And like imagine like the time, as Jake said, without generics in the language. It became a central feature for us. Last decade, functional programming came back. It was there before OO. And all of a sudden, functional languages like Scala appeared and became really popular. And maybe some of you might think, it's functional, there's no type, we are passing lambdas and functions around, right? So we gave up on type system again. Actually not. Functional programming languages are traditionally typed. And actually, types play a very, very important role in functional languages. So think about, you are mapping from one type to the other. Think about all these new types those languages brought us, like either. Like, there's a standard outside from arrow. There's a ton of new types. So functional languages use types a lot. They're basically built on top of it. Immutability, the core principle of functional programming. That is how we do OO nowadays, right? So don't think functional programming has nothing to do with types. Types play a very important role. So let's keep going. Yeah, the developers for JavaScript thought, did we do the right thing? So I found this quote by Anders Heisberg. You know, you can write large programs in JavaScript. You just can't maintain them. And actually, Anders, from what I heard, is a big fan of JavaScript. Here's some history. So he did TypeScript. He created C#. He created Delphi. He was the guy behind Turbo Pascal. So he has some background of language, so maybe we can trust him. So we kind of realized, okay, maybe JavaScript wasn't the best idea, but we can try to fix it with TypeScript. So types came back, so even at that part, right? Which I found very interesting. And then this endless fight with typed and untyped. A lot of researchers and developers thought us, maybe we're asking the wrong question here. Isn't it more like if we need to explicitly write the type, right? So fix the problem that Java and Co introduced in the first place. And we brought something back called type reconstruction, which you might have heard as type inference. It's the same thing. And type inference is an old concept, and Kotlin made it as its core. So we reached Kotlin by now. Java has now var, you know, since Java 10. So type inference was a principle that has been there, was basically discussed in all these decades. So it's not an old new principle. But finally, we put it in language and kind of brought all these specs together. When you think about Kotlin, a multi-paradigm language, a little bit of functional, it's OO, it's statically typed, but type inference, so hopefully this is the future. So Kotlin has basically types in its DNA, right? Think about nullability, like null safety into the type system. First-class functions. Think about nothing, like a type that represents the absence of anything. So it's just there so the compiler can check if this method returns. It's very interesting. So Kotlin tries to use the compiler as much as possible. So if Kotlin can do it, so can we. So we love Kotlin, but we still don't use the power of types. And this is basically because of this. Now let's talk about us, all of us here. We're all guilty of this. We are obsessed by primitives. This is not a term I came up with. This is an official anti-pattern. It's called primitive obsession. What does it mean? It means the usage of primitives instead of small objects for simple tasks. A user is not a string, but we all write it like this. A phone number is not a string. It's a phone number, but we always model it as a string. It also means using constants for coding information in there. Admin role equals 1. We are writing this kind of code. Think about it. We are writing it probably every day. This is primitive obsession. Probably all of us are guilty of this. So let's look at an example. You've probably written code like this. I have a value of time. It's a long on int. And then someone reviews the code, said, what do you mean time? What kind of time? What's the unit here, right? And then you fix it. It's time milliseconds. Said, yeah, you know, wouldn't it be better to not put it into the name? Yeah, sure, I can fix it like this. So it looks better, right? The readability is solved. It is still as unsecure as it was before. You can pass anything there. You don't have to check the type. OK, let's try to fix it again. How about making a data class and putting the time there? But now the millisecond thing is back. So we put it in the class called time, which is nice. But we still don't know the unit, only in the name. And come on, naming is hard. Don't put a type there. So we can do it like this. Let's separate those two. There's a value and there's a unit. If you don't know time unit, it's there in Java for a long time. You can use it in Kotlin. So now we have a class that separates value and the unit. And looks maybe hard to use, but actually you can write extension functions like this. And then an extension function on integer or long that creates you this time value. So use the power of Kotlin. And then go on, use the power of Kotlin for operator overloading. All of a sudden, you can have a time value in minutes and in seconds and subtract them from each other because it's a type. And you make it absolute safe. So first rule, don't put in a name what can be in a type. If you want to remember one thing from this talk, try to remember this. Don't put in a name what can be in a type. And when we think about this, as you realize I like to talk about history, when I started developing, we did this a lot. We put the information about the type in the names. We put in if this is a member, if it's a string. I even had like a company. If it's like an input and output param, it would all be in the name. It was called the Hungarian notation. And this is what Linus Torvalds thinks about it. Encoding a type into the name is brain damaged. And hopefully none of us has to do Hungarian notation nowadays. We gave up on it during the last decade. But although we gave up on the M underline thing, we still put a type into the name, like with the time milliseconds, right? We do it all the time. So maybe remember Linus Torvalds' quote here, and don't do it. So let's keep looking at our example. we had a method like this. So in my last company, we had like a video software, and you could cut a clip, and you would have a start time and a duration. And it was a suspend function, because of course it takes the time to create a video. And then I would call it like this, right? Cut clip, 5 seconds, 30 seconds long. Looks nice with the extension functions, right? But when I remove this, what does this mean? Is this a clip 5 seconds to 30 seconds? Or is this 5 seconds to 35 seconds? So is it start and end, or start and duration? I cannot tell by reading this method. So it means I can abuse this method. But to be honest, a good API should be impossible to abuse. Well-typed expressions do not go wrong. Remember this. Let's fix it. How about this? So we create classes for this. Point in time and time delta both contain the same information. They have the same time object, but they are different things. So let's express them as different things. One is a point in time, and one is a delta. And then actually what we can do is, hey, we can have both versions of this. This wasn't possible before. So you cannot abuse this, and whatever you want to do with the cut clip, you can use it right now. And now you probably see, come on, this is overkill. Actually, Kotlin time has a class called duration. It's in Java 103, still experimental, but it's there. Duration, they don't have a type here, but this is just because you use extension functions to create this thing. So if you thought that my milliseconds extension function int was a bad idea, JetBrains does not agree. They have, on all the numeric types, things up to weeks that you can call. And duration basically encapsulates. So this is how you create them, and internally they know that this is milliseconds or something. So instead of time delta, we can use duration now. And I hear this actually a lot about extension functions. So you're polluting the namespace of my integers or my string. This is just a problem because you're not abstracting them, because you're using the primitives directly, because you're obsessed with the primitives. If you hate them, you hardly ever see this. So it seems like JetBrains at least agrees with this one. This is cool. So I'll show you another example. Recently, I was refactoring. So we have some subscriptions at SoundCloud. I was refactoring this screen, and there was like some formatter, and it gave me like a price info and one on the discount price, just like a nice formatted string. And I made a mistake, and happily we had a lot of unit tests, so I cached this. But then I thought, wait, we have 2 prices here, and the only difference is the method name and the variable name. But why could I even make this mistake in the first place? Why could I pass in the discounted price into the regular price, or the other way around? It seems like we have 2 different things because we have put in a name what could be in a type. It seems our domain has a regular price and a discount price. Our domain says these are 2 different things. This is domain-driven design. Thank your domain rules and put them actually in your code. And don't put them in a name or in a document somewhere lying around no one ever reads. And as you can see, now both the methods can be called price info. We can just overload them. This reads so much nicer. So this is domain-driven design, very expressive. Try to use it. I'll show you another example. At SoundCloud, we identify most things like tracks, and users, and playlists with a thing called a URN. It looks like this. It's a string. There's some namespace, there's like identifier, like is this track or user, and some ID. And then we have a class to encapsulate this, because not primitive abstraction, right? And it looked like this, data class. And then you ask, hey, is this a track, is this a playlist, and so on. And I was looking at this, and I thought, it reminds me of this quote from Scott Meyer's Effective C++, a book from the 90s, one of the best written IT books. So anytime you find yourself writing code, if object is of type T, do something, otherwise do something else, slap yourself. Why? Because you have not understood object-oriented programming. You're doing something wrong whenever you do this. I used to have a post-it, like when I started programming on my computer, to know when I need to slap myself. So when I saw these type properties, I thought this is kind of the same thing, right? We had a method that tells me what type this is. So if you see something like this is a smell. There's, I think, probably a hierarchy here that we should use. And then I keep going, and then I saw is user and is valid user. So, and then in the code, we would usually first check if it's a user, and then also check if it's a valid user. So every time you use this, you have to do both. And it's easy to forget. Someone else like me comes into the team, right? And I didn't know that I have to check is valid user. So these are kind of dependent properties, but they're on the same level. I think there is a hidden type here. And then I saw like how we create those, and there's like a for user, a for command, so like factory methods, but they all return the same thing, right? Might be a smell if you see the factory method that return the same type. Doesn't have to be, but I think there are hidden types here. Let's try to fix it. So what we did is like, we have a sealed class, and there is a user URN. And only the user URN needs to check for is valid user. Actually, we need only is valid because we know already it's a user. So this looks so much better, and we actually extracted the types. And then when you use it, we had something like this. We had a command, and the command itself is identifiable with URN. And then there's a track that you're commenting on, so track URN. And there's a user that writes this command, so there's a user URN. And so 3 URNs, that's very easy to pass the wrong one. Also, like, look, one is called track URN, one is called commenter, so there's no alignment here. With types, we can simply fix this, right? Take the type out of the name. There's a comment URN, there's a track URN, there's a user URN. This is easy now. You cannot pass the wrong one. And actually, when you keep going, and this will happen when you go to domain-driven design, command is reply. Clean code will tell you if you ever pass a Boolean into a function, you're doing something wrong. Because this function, by definition, will do 2 things. But the method is only allowed to do 1 thing. If you pass a Boolean into a constructor, it's at least a smell. Because probably there's a hidden type here. There's a command and a reply, which is a special kind of command, right? So we could abstract here. We left it. But there's something else. You keep seeing these things when you start using more types. So I was then looking into this is valid of the user URN, right? I just showed you. And this was the implementation. It was basically checking if the ID of this user is not empty. So there's a user, but if the ID is empty, it's not valid, which makes sense. But my question was, why could I even create this, right? So I would call it don't let it creep in. There is a developer called Ivan Morgillo in Berlin. He talks about domain-driven design a lot. And here's a sample of a passport. When you go to the office and need a new passport, you give them all your documents, all your information, and you either get a passport or you're not getting a passport. You're not getting a passport where the name is missing, or where half the pages are missing. And every time you use this passport, you have to check, is this the one with the name? No. But OO is for modeling the real world. Why are we modeling the world like this? It's not existing like this. So don't let it creep in. So try to fix the things in the first place. So we could do something like this, right? We can have check it on the constructor. If it's empty, throw an exception. The problem is we are moving it to the runtime. The whole thing, my talk is about doing it compile time. So also you need to know in Kotlin we don't have checked exception. The constructor might throw an exception. So might be not the best thing, especially when you think about the error handling code you have to write here. So what we use a lot, developers, I mean, is something like this, right? You have like a method, create me a user. And it either gives you a user or null. Normal pattern. And then we can make the constructor private so that no one else uses it. So you have to go through those builder factory methods, however you want to call them, right? That's nice, but can we make this better? Sometimes I saw something like this. That you call the function like the class. You have to then put them in 2 separate packages, otherwise it will not work. You can't make it private, unfortunately, so you need to be internal, so you need a separate module. It kind of gets dirty here, but if you look at the usage, it looks nice. You're creating a user URN, right? But you're getting either null or user URN, which is kind of cool, but I don't like the different package thing and like that the constructor is not private. You can easily cheat this, but we're getting there. So let's go back to the original version with the for user. What else can we do? We can put it into the companion object, put it close to the object instead of having it outside. And then this is something that they do a lot in the domain-driven world, and call the method off. And then you use like user URN.off. So it's a method that either returns you a user or null. This looks nice. In functional world, they often call these smart constructors because they're more like they're like constructors, but not really, right? I think with Kotlin we can make this even better. What do you think about this? We can then invoke operator in the companion object, and then again this looks like a constructor. So because I call user URN.invoke, this looks really nice, but it's a constructor that is basically nullable. And now you can even go crazy. Maybe you have to have an email address that needs to be validated on server side, because you have to really check if this user is allowed. How about making this suspend? We can have a coroutine-aware constructor. I don't say do this, but all of a sudden you have these possibilities. So this is like the nice thing of Kotlin, right? We can do all these nice things. So smart constructors. But you think, yeah, Danny, this is like a really good idea, and I know we should get it, but the costs, this will be so expensive. Like allocation, memory, garbage collection. I mean, come on, who thinks here this is very expensive, doing like type everything? I have the wrong audience, that's cool. So I hear this, at least I heard this a lot. So let's talk about costs here. So what does it actually cost doing this and type all these things? So I would separate into the two things I just mentioned. Allocation, the memory that we need, and the garbage collection runs, and the cost of the garbage collection that we need. So we will focus on JVM, because this is my the area of expertise I can talk about. So JVM and Android. So allocations. You know, on a JVM, all the allocations happen in a thing called Eden space. It's like one big memory, and as you have multiple threads allocating things, you don't want to have thread synchronization. So it's basically split into a thing called thread local allocation buffers. So it's basically partitioned into small pieces of memory. The nice thing is there's no synchronization. Each thread has its own thread local allocation buffer. That means that allocating something is an increase of a pointer. That's basically it. There are actually some numbers. I can show you a link later, where I think from Oracle directly they came. So allocating something in a JVM, it's like 10 machine instructions. Doing the same thing in C, like a malloc, is between 60 and 100 on the best case. So you're 10 times faster, up to 10 times faster, because all you do is like allocating pointer. Of course, the buffer might be not large enough, but we're talking about very small objects here. So it's just allocating the allocating pointers. So there is no cost here. And actually, compilers are smart. The compiler might even inline your whole class without even making it inline. There's a thing called escape analysis. So the compiler will see, where's this class used? Does it even leave this method scope? If not, it will just remove this class. This is a very clever thing. Allocation, elimination. Again, trust your compiler. So allocations on a JVM are very cheap. But let's talk about Android. Android is always a different world, right? So on Dalvik, maybe there were like moves about don't allocate too many things, right? Like in the early days of Android. It is different. Art is optimized for allocations. And actually, last year's Google I/O, that's Chet Haas was saying basically this. Allocations are okay now. Types are okay. Yes, even enums are okay. So the ones who are laughing here are probably Android developer. They know that we had this thing, please use an int and not an enum. It's not a thing anymore. Chet said it, so you can watch that video. So types are okay, you can use them. So, okay, if allocations are cheap, we still have memory, right? So all these wrapper objects and wrapper of wrapper of wrapper, they will sum up. So let's look at this. So we have to pick like Windows and a very early Java, just to have some number that we can start working on. So plain objects back then had 8 bytes of memory. So I think we all can agree on that any wrapper around something will be 8 bytes larger than without. I guess that makes sense. But careful with assumptions on memory. An empty string is 40 bytes. Don't ask me on this machine. A Boolean, which is 1 bit of information, on a newer JVM, takes 2 12 bytes, the 1 for the information, plus 3 for granularity. There's actually optimization happening via the compiler on your machine. So sometimes it's quicker for the machine to read memory in certain blocks. So even if you have 2 bytes of information, it might read them in 8 or 16 byte blocks. So they might be padded. So don't make assumptions. This is actually what documentation said. The size of type is not defined. Don't trust this. So let's look at Kotlin. If you have something like this, like an age that is an int, the Kotlin compiler is clever. He will make this the primitive int into the bytecode. You can see this. So this is nice, right? Not much memory. But then you make it nullable because you have this special case, right? Now the Kotlin compiler cannot do this anymore, and although you just added 1 character, it will be much larger because you have a Java long integer. You have the boxed version of it. So let's look at my version. I would put it in an H, put the integer in there, and make this thing nullable. So now the Kotlin compiler can use the int in there. So I have an int and the cost of the wrapper. So this is already very close, probably, in cost of memory. We can make it inline. With this thing, the whole this whole method, the whole class, will be translated to an int. If you make it nullable, Kotlin will keep the H class, the Kotlin compiler, and the int will be an int. So the costs are not as high as you might think they are. So the last thing is garbage collection. So we talked about allocations, we talked about memory, so don't make assumptions on memory. But garbage collecting, come on. You're creating all these objects. You know, the performance of the garbage collector is not determined by the number of dead objects that you might think it is. It is actually determined only by the number of alive ones. The reason behind this is that we have, and this is the same on Android, we have generational garbage collections. So they have like an old and a new generation. And everything that happens in a new generation is very fast. So what takes time is finding all these alive objects and see if they have to move to the old generation. So short-lived objects are very cheap, even when it comes to garbage collection. And it makes sense, right? We talk about allocations. It's just like, okay, let's free this memory, decrease the pointer to make it very, very simple. So what I want to tell you, types improve your readability. Types give you documentation without you having to write Java doc. Put the information into the type. Type helps you with the compile time correctness. You get like a machine check documentation of the whole thing. As I said, let's try to avoid the bugs in the first place. And type actually improve abstraction. Not only because we're doing OO and we're modeling things. Think about you have to modularize your project. And then you have to think of where this price thing is used, like the discounted price. Find all the places and you want to have a discount module. It's impossible to find. You have to do a string search on your project. If this would be a type, all you have to do is check the usage of this type class. And then you see the things that belong together, and by Uncle Bob and the solid principles, if they change together for the same reason, put them together. So put them only in one module. So type actually helps you modularizing a project. Think about this. I think it's a very cool thing. So the message here is that types are actually enablers. Types enable a lot of things. So start watching out for these hidden types. All the type information that we put into the names. Look out for these is type attribute, right? I mean, there's always a reason why we did this. There's a reason why the URN, the user URN looks like this. It was Java. We had like a mixed code base. And for Java, there came non-nullable things in there and things like this. So, but if you find it, come on, do the Boy Scout rule. Let's start with a factor and come up with something new. You don't have to start with a new project. Booleans, if you pass Booleans into a constructor, think maybe, is this a hidden type? Do I just make it quick? And of course, look out for all the primitives that we write every single day. So let me end with Tony. Tony said, 1960, or 1966, you know, my goal was to ensure that all use of the references should be absolutely safe, with checking performed automatically by the compiler. He had this goal back then. 1966. But I could not resist the temptation to put in a null reference simply because it was so easy to implement. And we have this every day, right? That I know the right way, but you know, I want to go home. I want to push this out. He called it his billion-dollar mistake. He created the null pointer that we have until today. Kotlin saved us from this. But 1966, probably in that moment, he didn't thought it has such an impact. So please let the compiler do the work for you. Type all the things. And I have a lot of sources where I put these slides online. There's a lot of reads, amazing reads of like old papers and like researchers trying to understand how we came up with the type system. There's a lot of interesting blogs about how to best avoid primitives. Really nice one, let me recommend the one from Mark Seeman about domain modeling. He's really big in the C# community in F#. I just wrote last weekend, someone, after I did the first version of this talk at the meetup, said, you know, in Scala we have this thing called phantom types, and use this in builders a lot. So I read this article, and it was really cool, and I thought, can you make it in Kotlin? So this is my first version of it, but the Scala article is very long. So have a look. There are like interesting ideas there. And then, of course, if you don't believe the cost thing, there are a lot of sources for this too. So I thank you. Please remember to vote. I think I'll leave you a bit early. So come here, ask me a question afterwards. Thanks.